Hello and welcome to your video that really deals with fire, defects, possible decay of your wood. And so let's think about wood. I mean, is it really that durable? Well, here is the Horijuji temple in Japan that was built in 6007 AD. That's over 1400 years old. You have buildings all over Europe that are timber buildings, and they're called the half timber buildings from the Middle Ages. The buildings last for a long time, and timber is durable if protected correctly. But let's talk about the things that can cause damage to timber. So the first is fire, and fire is a real deal. And we talked about that wood can char. And so what we mean by char is here's a bunch of pictures of charred logs that have come out of a forest fire and have been cut for collection. And we mentioned that you can have steel beams melt in a building while the wood beam carrying them chars. But of course, today we put fireproofing over top of, and I'm not trying to mislead you if we're talking about stick framing. 2x4 studs at 16-inch on center, 2x6 studs. Those will not char and they will go up like a matchbox. So dorms, houses, things like that, you have to make sure that you've got your drywall on there, which gives you protection. You want to make sure in residential buildings, like the dorms, that you have doors that shut between stories or whatnot, or between sections of the building to give you additional fire protection so the fire can't travel. But when we're talking about larger members, 6x6 and larger, we can start to see this charring behavior happen. So what is happening during char? Well, basically what we can say is the exterior of the wood heats up, burns, but then stops burning and creates this char layer that protects the through heating of the additional wood. And what's really happening, which is fascinating, is it heats up really quickly, and then before it can keep burning through, because the member's so thick, gases that are deeper in the timber from the heat start expanding, and then they need somewhere to go, and so they eject out and actually cause convective cooling that's happening. And then you actually get those gases, they could combust, but as they move away, they do something called transpiration heat blocking. And this is something that's used in radiant cooling systems or in refrigeration, where you can actually create a transpiration layer which cools things and stops heat from coming in. So it's kind of really cool mechanical engineering or thermodynamics effect that happens. If wood was going to burn, you do have to have temperatures over 250 degrees Celsius, and it has to be over 500 degrees Celsius to spontaneously combust. This is still lower than where steel switches into the austenite zone, but not lower than where steel will start to lose mechanical properties. So fire is a concern in wood, and it's something we should always pay attention to. The other thing that's a real problem in wood is going to be things that degrade the wood. And so that could be anything from insects. So we see some possible insects here, whether it's a beetle or the marine borers or termites, to you can have trees that are attacked by bacteria that can really hurt it. Typically, once the wood is in your house, that bacteria is not an issue, but it would make lumber out of that tree unusable. And then there's this crazy fungi that causes rot. So let's look at rot. So it truly is, when people say the wood decayed or the wood rotted, it's a fungus that has been eating the wood that has caused it. Now that fungus needs four things, four very important things. It needs air, it needs moisture, it needs food, the wood, and it needs some warmth. The amount of moisture that the fungi need to actually survive your wood has to be over the fiber saturation point. So if you have your house properly protected and the wood stays dry, this is never a problem, okay? And in fact, this is though really interesting, is that fully submerged, say, wood piers for a pier, they actually will not rot, because once the wood is underwater, there's no air. It's not even just about oxygen. I mean, it just needs the air. And so fully submerged wood. The Taj Mahal had piers underneath it, large wood piles that were fully submerged because of a high water table when it was constructed, and they've lasted 100 years. but the water table is lowering there now, and they're having trouble with the upper layers of the wood rotting because it's in contact with the soil and can get air, and it's warmer, and it's not submerged in moisture. So here is an interesting picture because we hear about a lot of woods being naturally resistant to rot. Redwood, cedar, main examples. Well, in this particular board, it is very easy to see the heartwood of the board, and then this very distinct demarcation where we switch to sapwood, and it's discolored, and we also have fruiting bodies of fungi growing on this piece of wood. This is to the air out here. This is the bottom side of a deck, and you can see the deck boards joined together with a topping surface on top. And so, yeah, you could say that cedar is supposed to be rot resistant or fungi and insect resistant, but only in the heartwood. And that's a huge selling point that most people don't realize, and they get sold sapwood because it's cheaper, or get charged for sapwood without knowing it. Here's another amazing shot of rot that has occurred of the wood. And so what's going to have been happening here is either water maybe coming down from rain and then getting trapped underneath, so this is just sitting in moisture, or there was a flood and it stayed in moisture. It's hard to say, but typically it just has to do with your siding, and the way that you get rid of water is not done well. This concrete should be sloping away. It doesn't look like it. And today, you can't put just a regular 2x4 down as the start of your building as your sole plate. You actually have to use treated lumber to help resist against rot. And so, in addition to this fungus that can eat it, the other living things that are trouble are your insects. So we've already mentioned some marine borers and termites, beetles, but there's also carpenter ants. There's a lot of things that can destroy your wood. One of the things that's really important is your wood should never be in direct contact with soil. In California, if you crawl under a house, there's supposed to be 18 inches between the finished grade of the soil and your first piece of wood. Not true in your older homes. But we can treat wood to resist the insect attack. Now, the reason you need that 18-inch clearance is termites like to build mud tunnels, and they'll literally build these mud tunnels up your wall so they can get to your wood. It's creepy. And when they do get to your wood, what you're looking at are things like just eaten out from the inside. You might not even realize how bad it is. Maybe they ate mostly on the inside, but you go to scrape it with a screwdriver or something, you can just push it right in as if it's pudding. It's really loose. So how can we resist this fungi? How can we resist against insects? Well, there's different treatments that we can do. Petroleum-based solutions are nasty. And you've all seen them sometime. If you've ever gone near a telephone pole on a hot day and it stunk, it's because it's being treated with a creosote, which is petroleum-based product. There's also the pentachlorophenols, which aren't nicer either. These can be toxic. You can't paint them. They're dirty. You lean against them. The stuff will come off on you. They smell bad, right? But they're very, very, very effective. And so they're used in places where people aren't supposed to be hanging out regularly. So telephone poles, railroad ties, that sort of thing. What's more commonly used in homes and sometimes fence construction, or at least fence posts construction, is going to be regular wood that's been impregnated with a water-based solution that includes some form of a copper arsenate. And there's 3 or 4 different kinds out there. One that's out there, which is called a copper quad, it's ACQ, and it has ammonia in it. This actually can eat through fasteners unless you use stainless steel, so it can actually corrode your metal, so that's problematic. But the nice thing about this pressure treated, and so here's an image of it, is that you are able to paint it. It's cleaner than creosote. When you're cutting it, you should really wear face masks. It has a slightly green color to it because of the copper. Here's a brand that's really green that comes out. And a fun one is this blue wood product, and it's literally called blue wood. It's supposed to protect from termites, rot, moisture, everything. And so in the South, where that can be more problematic with the moisture, the entire house can be this blue color. It's quite Smurf-like. But the nice thing is say you want to build an outside pergola, if you're going to paint it a certain color, you can use this blue wood, and then this is totally paintable. A final method that people have been investigating is taking advantage of wood's natural resistance. And so remember, when we talk about, say, redwood, here's a bunch of redwood posts, we have our heartwood that has the natural resisting ability inside of it. And so companies like Cedar Shield, they promise that if you use their product, it contains the same chemicals that make cedar or the heartwood of cedar naturally resistant, and you can soak your wood in this. According to their reviews, it's not 100% effective, but maybe people didn't use it right. I don't know. I haven't used it. And then there's some stronger materials. So there's something called tourmaline TT solution, and this is a great image. So they took these boards and they buried them for like 3 months in the soil in an area that was known to have termites primarily. And so here's what they put in the ground, and here was an untreated board that they put in the ground 3 months later. Now, there was a product called DDAC that they typically would tell you you can mix with a solvent, or that the solvent would also help resist. So here they just used the solvent only, and here are the solution percents that they used. And 3 months later, there's not a lot of wood left. Here was using this DDAC with the solvent, and we can see that 3% did pretty good. Again, this is buried wood. You typically don't bury wood, but that just gives you, to speed up the process of the termite attack. And then we get to the tourmaline TT, 0.5% didn't do very good, but we can see 1, 2, and then 3. 3 basically looks like the original board. So that it did a great job resisting. So we can protect wood from insects. We can protect from fire if we build correctly, and we can definitely protect from moisture if done well. And wood is a beautiful natural. It is a renewable resource, but we do have to be careful how we manage our forests, because when we cut down the trees young, not only do we get less strong wood, but we also cut them down before they really even hit their peak carbon sequestering capacity. But at least it's still a renewable resource. Hope you've enjoyed wood. Thanks for watching.